This is the second video of oxidation reduction reactions. So in this video I want to talk about oxidation states. So we need to know, when we have two reactants, we need to know which one of this reactant we have oxidation and which one is doing reduction. So identifying whether or not a reaction between a metal and a non-metal is a redox reaction. And it's fairly straightforward because of ion formation. So you know metal is usually losing electrons and non-metals usually gain electrons. So but how do we identify redox reactions that occur between non-metals? So we for example, when we have two non-metals, we can track electrons before and after a chemical reaction using the concept of oxidation states. Each shared electron is assigned to the atom that attracts the electrons most strongly. For example, oxidation state or oxidation number, we can use that to see which one has more attraction. So we use oxidation state or oxidation number is given to each atom based on the electron assignment. The oxidation number of an atom is in a compound is the charge it would have if all shared electrons were assigned to the atom with the greatest attraction for those electrons. For example, we have HCl, we have hydrogen and chlorine. Since chlorine attracts electrons more strongly than hydrogen, we assign the two shared electrons in the bond to chlorine than H. So all those two electrons gonna go toward chlorine because that one has more attraction. So hydrogen, which has lost an electron, has an oxidation state of +1, and chlorine, which has gained one electron, has an oxidation state of -1. So that's what we need to do for covalent bonding. So let's have some rules. So we need to see some rules for assigning oxidation states. Number 1, the oxidation state of an atom in a free element is 0. For example, we have copper, it is 0 oxidation state, or chlorine, 0 oxidation state. So the oxidation state of any atom in a free element is 0. An atom in an element is 0. For example, sodium, oxygen, ozone, and mercury. Number 2, the oxidation state of the monoatomic ion is equal to its charge. For example, we have calcium. Calcium usually lose 2 electrons, so we have calcium 2+. So the oxidation state of calcium is +2. And chlorine should lose gain 1 electron, so it's going to be -1 oxidation state. So a monoatomic ion is the same as its charge. So as you see here, we have Na+, which is going to be +1, and Cl-, which is going to be -1. So number 3, the sum of the oxidation states of all atoms in a neutral molecule or formula unit is 0. So when we have neutral molecule or neutral compound, so the summation of all these oxidation states must be 0. For example, we have 2 atoms of hydrogen plus 1 atom of oxygen. So 2 times the oxidation state of hydrogen plus 1 times oxidation state of oxygen has to be 0. Number 4, the sum of the oxidation states of all atoms in an ion is equal to the charge of that ion. So that's the difference between number 3 and number 4. Number 3 belongs to neutral molecule or neutral compound. As you see here, it has to be 0. For here we have ion. So this ion has -1. So the summation of all oxidation states for all these atoms must be equal to -1, as you see here. So we have 1 atom of nitrogen and 3 atoms of oxygen. So 1 times oxidation state of nitrogen plus 3 times oxidation state of oxygen. It has to be equal to -1. Number 5, in their compounds, metal have positive oxidation states. For example, for group 1A and group 2A, it's very straightforward. Group 1A metals always have an oxidation state of +1, and group 2A metals always have an oxidation state of +2. As you see here, we have NaCl. Na belongs to this group, group 1A, so it's going to be oxidation states plus 1. CaF2, calcium, belongs to group 2A, so the oxidation states plus 2. So 6, in their compounds, nonmetals are assigned oxidation states according to the table at left. So for example, fluorine is -1 in its compound because it belongs to group 7. So fluorine is -1 because usually it gains 1 electron, HF and PF3. Number 7, the oxidation state of any given element generally depends on what other elements are present in the compound. The exception are the group 1A and 2A metals, which are always +1 and +2. So that's rule 7 is very, very important. I'm going to read it again. The oxidation state of any given element generally depends on what other elements are present in the compound. So this rule is usually combined with these two, 3 and 4. As you see here, when we have neutral molecule, it has to be 0, and when we have ion, it has to be equal to the charge of the ion. Okay, that's the end of this video.